All right, so this is a recording that I'm doing for section 4.2. Let me share my screen and let me, where you're going for part of the homework for 4.2 is you're going to be using StatKey, and we're introducing another distribution over here to the right. We have these randomization distributions that are going to help us find p-values for hypothesis tests. And when we're working on this lesson, we're going to run into an example where we need to use the randomization distribution. And I have an example in your homework. Um, the handout and your homework will have guidance on what to do, but watch this video to help out. But what we're doing here is we're doing a hypothesis test that in one piece, in one of the claims, it's supposing, that it's supposing that the proportion for a parameter is at 0.6 or 60%. But suppose someone is challenging that claim and suggesting that alternatively, the proportion is higher than 60%. And we do pull an original sample of 80, and out of that 80, 52, or as a decimal 0.65 is the sample proportion that we get. And so what we're going to do is we're going to create what looks like this, a randomization distribution to calculate the p-value or the chances of that statistic happening by random chance. So there's several different boxes that we're going to be playing with. One of them is that you need to put in what is supposedly the true parameter of 0.60. And then you need to generate many samples in order to see the probability of all these different samples happening. So let me take you over to StatKey to show you what we're going to do and what you'll do in the homework. So we're doing a test for a single proportion. And when it starts off here, it wants to know, what are you supposing to be the true proportion? And in the example that I'm doing for the lecture, we're supposing that it's 0.6. And so I'm going to click on this blue box here. And it asks me, what do you want to suppose is the true parameter, 0.60 or 0.6? You click OK. And it's going to do, what it's going to do is it's going to put that here at the center, what you're supposing to be true. And we want to see if our statistic from our original sample is near here or far enough away to contradict it. Now, you also need to update the information for your original sample, because it's going to start off with something that may not be what the homework is asking for. So they want us to put in here, suppose that our original sample was 52 out of 80. So to change this, you need to go over here where it says edit the data. And so you need to put your numerator 52 out of 80 and click OK. And now you see over here that you've got what's supposedly the statistic that came from a sample, 0.65. And we're hoping, a researcher would be hoping that that's far enough away to contradict or to give us evidence against the null hypothesis. Right now, it's still pretty blank. And so you want to generate, I think 1,000 samples should be plenty. I'm going to click 1,000 samples. And in the lecture, we'll talk about what all this here means. And real quick, it just means in the center is all of the likely things that would happen or the statistics that you might get by random chance. But we want to see where our original sample statistic lies in respect to all these 1,000. And so the last thing you need to do is you need to click on the right tail. And the reason why I'm doing right tail, again, we'll talk about this in the lecture, is we're checking to see whether the proportion, going back to the handout, whether the actual, if we have evidence that the proportion is greater or higher than 0.6, essentially to the right side. And so when I click that, notice I'll click it on and off. When I click on the right tail, it generates just some statistic down here, but we want this to be specifically our statistic from our sample, which is the 0.650. So when you click on this down here, it will let you change it to 0.65. You don't need the O. It's just an extraneous zero or an extra zero. And it will show you how likely this was to have happened by random chance. And what it's doing is it's counting all of the dots that are as extreme or more extreme than your observed statistic. And it's also giving you a p-value up here of 0.223. And this is what you're going to report. And you're also going to turn in this entire randomization distribution to show that you were able to go through and find the p-value for a statistic. That is what you need. Follow this example when you're doing your homework. The null, the original sample might be different numbers, but you're going to walk through the same steps. The other thing that I'm going to show, in case you want to also do for an exercise, the example that's here in the lecture about Paul the octopus. Paul the octopus is being tested to see whether he has this ESP power or maybe whether he doesn't. And so in lecture, we'll do this one, but the way that I'm doing this one is through the exact same tool that we just used. So you go to StatKey, test for a single proportion, and play around with these other ones. We will eventually get to all of them, but test for a single proportion. And what they were testing to see whether Paul was just guessing more than 50% correct. So we want to leave the null hypothesis here at 0.5. But what we do want to do is also put what Paul was able to do. He's our original sample. And what he was able to do, we need to edit over here. He was able to predict the winner 8 out of 8 times, meaning he got like a perfect score. And so that now is Paul over here, the original sample statistic. And we want to see how likely it was for this to have happened by random chance. And we're going to generate 1,000 samples. And so this is what may have happened in a 1,000 times just randomly. But we want to also do the right tail again, because we're seeing that Paul is doing greater than 50%. And so you click the right tail. Again, I'll click it on and off a few times just so you can see that it's changing. And again, it gives you some statistic, 0.875, but this is not Paul. Remember, Paul was 1.0. He was 8 out of 8. So you can click this and you can put what Paul's statistic was, 1.0, hit enter, and it will show you here how likely this was to have happened by random chance. Essentially a p-value of 0.003, which is suggesting very extreme, very rare. And the further you are away from the null hypothesis, the more of the more that the sample contradicts it, so that you have evidence for your alternative, or other words, evidence against the null hypothesis. So this is how we're going to do the example in the lecture. But I'm going to go ahead and hit stop here, because that should help you when you get to that exercise. All right, take care.